function, factorial function. Now, there's a very important remark. The recurrence relation 2, which we have defined, gamma n plus 1, this is the recurrence relation 2. Not this. The recurrence relation 2 is this here. This is 3. Gamma n plus 1 is equal to n gamma n. N gamma, this is a recurrence relation 2 in your page number 1. There's a very important remark which I have mentioned in the notes, that the recurrence relation 2 is difference equation which has 1 as a solution. The solution of this is the gamma function. The solution of this relation is the gamma function. If you solve this, the solution will come out to be a gamma function. So sometimes people use this equation 2 as the definition of the gamma function. So sometimes people write gamma n is equal to, sometimes people write this gamma n is equal to gamma of n plus 1 divided by n. Sometimes people use this definition as the gamma, as the definition of the function, as the definition of the gamma function. But the basic definition of the gamma function is in terms of the integral, which is in this is given on page number 2, equation number 5. So some people write gamma in terms of gamma, but that is not a proper way. But people use it frequently. That is why some people take it as a definition of the gamma function. But the basic definition is same. The basic definition of the gamma function is gamma of n is equal to t x raised power n minus 1 into e raised power t, e raised power minus x dx. So this is another very important property of the gamma function. This process is called analytic continuation. Any question here? Okay. This process of continuing this gamma n plus 1 is equal to n factorial. This process is called analytic continuation. But sometimes we can even find gamma minus half. But n is positive, so sometimes this gamma minus half, we can find gamma minus half. Put this n is equal to minus half in the equation 5, in this equation, that is in equation gamma n is equal to gamma of n plus 1 divided by n. So this, if you put gamma of minus half, put n is equal to minus half in this equation, you will get gamma of half divided by minus half. But you assume this gamma of half, you don't know gamma half. Gamma half we will find it in the later part of the class. It is assumed that gamma half, the value of the gamma half is for time being, you assume that the gamma half is root pi. Root pi divided by minus half. That is gamma. Therefore, we found that gamma half is defined, but in terms of not directly from the function, not directly from the definition, but from this relation, recurrence relation. From here, we got the gamma minus half. It is root pi by 2, but you have to assume that gamma half, for time being, you assume that gamma half is equal to root pi, which you will find when you will go for double integration, which will be done in due course of time. So you assume that you assume for time being that gamma half, the value of gamma half is coming to be root pi. It is not found directly. We have to use the double integration. So that is given on page number 2. So we are able to, very important conclusion. We are able to find gamma minus half, but not from the definition, because definition is valid only for n greater than 0. For n greater than 0 is less. So, but we are using the recurrence relation to get the value of gamma minus half. Now, go to page number 3. Very important, but this is important in the sense you don't use it, but you must know about it. Asymptotic formula for gamma n.
Battle Royale. Battle in style.
Asymptotic
Head to the vending machine.
formula
Head to the tech workshop.
for gamma n. Mr. CR, you got the same notes or different notes?
Same notes.
Okay. Notes are with you right now?
Yes.
Okay. So we are on page number 3.
Heads up. Enemy
This
dropping
is
close.
something you don't need, but I will tell you. Some people are interested here. If n is large, in gamma
Got
n
a gun!
is large, the computational difficulty is inherent in calculations of gamma n are apparent. So there are computational difficulties. If n is large, obviously, then gamma, then it is very difficult to evaluate the integral. If n is large, the useful result in such case is applied, which was obtained by Stirling. He has obtained this relation. Very large. Then what he has obtained? He has obtained a very good relation of gamma n plus 1. Gamma n plus 1, he obtained it like this: root 2 pi n n to the power n e to the power minus n into e as power theta divided by 12n plus 1. 12n plus 1, it is in denominator, where theta is between 0 and 1, very small number, 0 and 1. This formula has been obtained by Stirling for larger n. Now see, for most practical purpose, the last factor means e raised to
Help
power
me!
theta divided by 12n plus 1, because n is this theta is small, theta is between 0 and 1.
Capturing the revival point.
This is the last factor in that formula. For most practical purpose, the last factor, which is very close to 1, this is very close to 1. For large n, obviously large n, this will be very close to 1, can be omitted. So this whole factor can be omitted in that Stirling's formula. So if n is an integer, then we can have n factorial is equal to gamma n plus 1 is n factorial. N factorial is equivalent to, because it is equivalent to, because there is some error, very small error, that's why it is not equal to, but approximately equal to under root of 2 pi n to the power n e to the power minus n. So we are able to find, for larger values of n, we can find the gamma. N factorial is equal to gamma n minus 1, obviously. So this is sometimes called Stirling's factorial approximation or asymptotic formula for n factorial. N factorial being in terms of the gamma function. So sometimes you people, those who are doing civil engineering or mechanical engineering, they use frequently this formula. They apply this formula frequently. It's a very important formula for them. So let's see now. This is all about the way how we go with gamma function. Let me go to the problems now. Page number 3. We are going to the problems now.
Go for the arsenal.
Now, if you see in the sheet on page number 3, the first one is find gamma
Still on
6 by
cooldown.
2 gamma 3. So you will find it. Gamma 6 is okay. Gamma n plus 1 is gamma n is n minus 1 factorial. So gamma 6 will be pi factorial divided
Still
by,
on cooldown.
because gamma n will be n minus 1 factorial by the previous property of gamma function. It is 5 factorial divided by 2 times gamma 3 is 2 factorial. You will get the value. The value is coming to be 30. Then this was the first. Then the second problem is gamma pi by 2. Gamma pi by 2. Gamma half. Obviously, how you will do it? Gamma n is n minus 1 factorial. Or you will write 3 by 2 plus 1. Okay. So you will get 3 by 2 into gamma 3 by 2. Then there is gamma half. You go again for 3 by 2, you will write 3 by 2 into gamma into 1 by 2 into gamma half. So you will get 3 by 2 into 1 by 2 into gamma half divided by gamma half. We assume that gamma half is root pi in previous case. So gamma half will go. So you will get 3 by 2. So this is how we evaluate the numbers with the help of the gamma function. Let me go to the page number 4. There is another problem. Problem 2 on page number 4. Evaluate integral 0 to infinity. The notes are very. There is nothing to. Hello, salam alaikum. Hello.
Go for the arsenal.
Walaikum salam. Arsenal is very keen. Arsenal is keen. That's your last. So we have 0 to infinity x cube e raised power minus x dx.
Follow me.
Now see, there is
Arsenal
nothing to
unlocked.
evaluate. I have evaluated everything.
Help me.
Everything, step by step evaluation is there in your notes. So if you find what is your gamma function, gamma n is equal, if you find gamma n is equal to x raised
Come here.
power n minus 1 e raised power minus x dx.
Come here.
See here in this, now see the
Need
problem.
equipment.
If you put n is equal to 4, you will get
Help
x
me.
raised power 3 here. If you put n is equal to 4 in the gamma function, you will get x raised power 3 into e raised power that is my integral.
Thanks.
And integral is from 0 to infinity. So this is nothing but this is gamma 4. Gamma 4 is 3 factorial. 3 factorial is 6. So very simple. Otherwise you have to use improper integral technique to find the integration of this. By gamma function, it is very easy. Put n is equal to 4. Okay, then the next problem is next problem about gamma function is x raised power 6 e raised power minus 2x dx. Now see, you need only x here. You need x only. In the gamma function, your function will be e raised power minus x. So you will put 2x is equal to y. You will put 2x is equal to y. Because why we put it? Because we need only e raised power x minus x here. So I will put 2x is equal to y. Then you evaluate it. Then you will get, if you evaluate it, you will get 0 to infinity. There is no change. It is y by 2 or raised power 6. Because x raised power 6 will be y by 2 or raised power 6. It will be e raised power minus y into dy will be dx will be dy by 2. When you will evaluate it, you will get it 1 by 2 raised power 6 into 1 by 2 go 1 by 2 raised power 7 out. 2 raised power 7 out. Then you have 0 to infinity y raised power 6. Then raised power minus y.
Help me.
You will find that this is equal to 1 by 2 raised power 7 and this is y raised power 6. So it is gamma 7. Gamma 7. 7 minus 1, 6. Gamma 7. You got well. It is 1 by 2 raised power 7 into gamma 7. You will write gamma 7 is equal to
Help me.
6 factorial. It is 6 factorial by 2 raised power 7. So this is the answer of this problem. Now important, very important. Now I am writing here very important integral. Very important integral. This is what I told you. This is called the Gaussian integral. Some people call it the Gaussian integral. Gauss integral. What is that? Now this is Gaussian integral is something I will tell you. It is something e raised power minus u square
Capturing
is
the
minus
revival
x square
point.
dx is called the Gaussian integral. This is called the Gaussian integral. This integral is called the Gaussian integral. So all are hereby asked to mute your mics. Please mute your mic. So this integral is called the Gaussian integral. This integral e raised to power minus x square dx is known as Gaussian integral. And now here in gamma function, what we have to do? The next problem is gamma half is equal to, I will discuss it in the later part of the class. It is equal to root pi, and some part of it will be done in double integral. So that gamma half is equal to root pi. I determined it root pi, but in a different way by using the reconciliation. So if you directly apply gamma half, the definition of gamma half, you can write it n is greater than 0. It is greater than 0. It is 0 to infinity used in the definition of the gamma function. 0 to infinity x raised to power minus half e raised to power minus x dx. So what you will do, you need here 1, so put x square is equal to u square. When you put it here, you will get gamma half is equal to 2 times 0 to infinity e raised to power minus u square du. This integrand is called a Gaussian function. The integrand means not the whole integral, not integral only. The whole integral is called a Gaussian function. So it is 2 times 0 to infinity e raised to power minus. So we got that gamma half is equal to 2 times integral 0 to infinity e raised to power minus u square into du. Thus, this integral is not easy to determine. You have to use double integration. So when you use double integration, we know that it is 2 times the integral is coming to be equal to root pi by 2. You will find that in double integral. When you will go to the double integral, the integral will come to be root pi by 2. Remember it for up to that time.
Help me!
So you will this will cancel that this root pi. So we have determined that gamma half is equal to root pi, but with the condition that you don't know the value of e raised to power minus u square integral 0 to infinity is coming to be root pi by 2. For time being, you remember it.
I
When
need
we will go to
equipment.
the double integral, we will do it there. We got that here gamma half is equal to root pi. So I have written your notes the result of double integration. Now there is another problem that is shown in your sheet on page number 4. Evaluate another problem. Evaluate. Not doing it. The proof is there. The solution is there. Integral 0 to 1 dx divided by minus ln of x. You will do it by make some substitution there. Put u is equal to minus ln x, and you will proceed. Again, you will use gamma half is equal to root. This is all about the gamma function. Now let me go to the beta function. Page number we are on page number 5. Beta functions, it is not. We denote the beta function by b of mn. We denote the beta function by b of mn, and it is defined as x raised to power m minus 1 into 1 minus x whole raised to power n minus 1 into dx, and your limit of the integration is from 0 to 1. While m and n they are positive, greater than 0. M and n they are greater than 0. So this is again an improper integral, because there are conditions are m and n. So it is x raised to power m minus 1 into 1 minus x whole raised to power n minus 1 dx. M is with x raised to power m minus 1, 1 minus x whole raised to power n minus 1 into dx. Now there are some useful properties for this. The first property is beta of mn, beta function beta of mn is same as beta of n, symmetry on m and n. They commute n and m, so you can interchange them. Mn is same as nm. So you can prove it. You can prove it by using the definition. The proof is simple. You can use the definition beta of mn is equal to what you will do, x raised power 0 to 1, x raised power m minus 1 into 1 minus x raised power n minus 1 into this. Put x is equal to 1 minus 1.
Free Fire
y,
India?
Sorry, put x equal to 1 minus y. You get the value of beta mn as, you get beta mn as 0 to 1, 1 minus y whole raised power m minus 1 into y raised power n minus 1 into dy. Okay. So what you will do now, the next step is 0 to 1. Y raised power n minus 1 is there. 1 minus y, you can transfer it here and there. Because they commute inside the integral, it is m minus 1 into dy.
Battle Royale. Battle in style.
And here is m here.
Head to the vending machine. Head to the vending machine.
1 dy. So we see that beta of mn is same as beta of n. This is the first property. The second property is this is a very important property. Beta of mn is equal to
Heads up! Enemy
beta of
dropping
mn
the
is
boat.
equal to 2 times 0 to pi by 2. Page number 1 and page number 5. Sine raised power 2m minus
Got a
1
gun!
into theta into cos of 2 raised power n minus 1 theta, then d theta. So what you will do here in this property, very simple. Put x equal to sine square theta in the definition of the beta function. In the definition of the beta function, so you will get the solution. Because m2 raised power m minus 1 will be there. dx will be 2 sine theta, cos theta, and d theta. One sign will go with one sign, another sign will go with another sign. So you will get 2m minus 1. Okay. This is another property that beta function is in terms of the trigonometric function is 2 times integral 0 to pi by 2, and the limit will change from 0 to 1. From 0 to 1, it will change from 0 due to this transformation. When x equal to 0, sine 0 is equal to 0. When x equal to 1, sine theta is equal to pi by 2. Theta is equal to pi by 2. So this is another property of beta function. The third property is very important. Very, very important property. Third one is beta of mn. Beta of mn is equal to gamma m, in terms of gamma function now. Gamma m, gamma n divided by gamma of m plus n. Where mn, they are positive. So this is very important, very important property. Because why it is important? Because it gives the relation between beta function and gamma function. It gives the relation between beta function and gamma function. Beta of mn is equal to gamma m, gamma n divided by gamma of m plus n. The proof I will provide you the proof. What you will do? The proof is given. I hope you will find the proof in the sheet. I have put z is equal to x square in the gamma function. So your gamma n is gamma n. If you remember, it gamma n is equal to 0 to infinity. X raised power n minus 1 e raised power minus x
Enemy spotted!
dx. So this is the definition of the gamma function. So what I will do, e raised power minus x dx, put z is equal to, so you will write z is equal to x square. What you will do, you will write gamma m is equal to, then z is equal to x square. You will get 0 to infinity. Z raised power m minus 1. Z, it is m here now because n is already there. So e raised power minus z, then dz. Okay. So you will get, this is 2 times z is equal to x square So it is 0 to infinity 2 times 0 to infinity x raised power 2m minus 1 into e raised power minus x square, z is x square into dx.
I'm being haunted.
Similarly, this is gamma n. Similarly, you will find gamma n. Another variable you use the variable as y, which is 2 times gamma n, 2 times 0 to infinity y raised power 2n minus 1 into e raised power minus y square into dy. Then product both. When we'll find the product of gamma m n, product both gamma mn, you will get this integral. You will find the integral there. So we will get the integral there. Now then I have used
Help me.
4 times. Let me get the integral. 4 times. It's very simple. Calculations are there given. 0 to infinity, 0 to infinity. It is x raised power 2m minus 1. Y raised power 2n minus 1. Page number 6. E to the power. This factor is very important. This is the Gaussian function. Same. X square plus y square. In terms of two variables now. Dx dy. This part is the Gaussian function. In terms of two variables. X square plus y square dx dy. Now what you do, you put here some polar form. X equal to r cos theta and y is equal to r sin theta. Then dx dy will be dx dy. What is the value of dx dy? It will be dr d theta by Jacobian. You will get this dx dy as this. When you put these these polar coordinates in your this integral, you will get very important part, which is 2 times, which is something 2 times gamma of m plus n into theta is equal to 0 to pi by 2 cos of 2m minus 1. The earlier integral which I told you, cos of 2m minus 1 theta sin of 2n minus 1 theta, then d theta. And this we have found that this value is equal to gamma of m plus n. This is beta of mn by 2. 2 will go. So gamma of mn is equal to, so we have got gamma of mn is equal to beta of mn is equal to, so we have got beta of mn is equal to gamma of mn, so we have done some mistake. Yeah, this is on the left side. Be careful. This is not gamma. This just make the correction on the left side. It is not gamma of m into n. It is gamma of m into gamma of n. The correction is in your lecture notes. It is gamma of m into gamma of n. It is not gamma of mn. Gamma of m. Just make the correction. Gamma of m into gamma of n, not gamma of mn. It is gamma of m into gamma of n. So we got gamma of mn is equal to, beta of mn is equal to gamma of m into gamma of n divided by gamma of m plus n. Correct, calculation is correct, but there is some notation here. It is gamma of m into gamma of n, not gamma of mn. Because we are multiplying two integrals. You see, on page number 6, we are multiplying two integrals 4 times this. One integral is 2, another integral is 2, it is 4. Then one integral will gamma n, then another integral will gamma n. So it is gamma m into gamma n, not gamma mn. This is wrong, because we are multiplying two integrals. So therefore, this relation is very important for relation between beta function and gamma function. So we have very important relation that beta of mn is equal to gamma of m, gamma of n divided by gamma of m plus n. Now let me do some problems about this. So let me evaluate. One integral is 0 to 1 x raised power 4 into 1 minus x 4 raised power 3 dx. So if you compare it with the beta function, it is 4, m minus 1. So m is 4, m is 5, n is 4. This is m minus 1, n minus 1.
Capturing the revival
this
point.
beta of 5, 4 by the definition of the beta function. What is that? Gamma of m, gamma of n, gamma of m plus n. You will find it. Gamma 5, gamma 4, gamma 9. So you will find it. So this is very important now. See how we are able to evaluate such integrals when you are familiar with the beta function as well as the gamma. Now there is another integral. Let me do one more integral here. Evaluate 0 to pi by 2. Some examples I am speaking for you because they are given there in the sheet lecture notes. So this sine of 6 theta d theta. So what I will do, if you remember the earlier result, sine of 2m minus 1 into theta cos of 2n minus 1 theta. With sine there was 2m minus 1. So what I will do, I will put this 2m minus 1 is equal to 6. That is sine of 2m minus 1. So put 2m minus 1 is equal to 6. Let me put 2m minus 1 is equal to 6. How it is coming? Because we have that result. Sine to the power 2m minus 1 into theta cos of 2n minus 1 into theta 0 to pi by 2 is equal to beta of mn. That is why I put 2n minus 1 is equal to 6. So I got the value of f.
Free Fire India is set.
2n minus 1, 2 raised to 2n minus 1 is equal to 0. Because there is no cosine term. So you got
Battle
value of
Royale. Battle in style.
6 plus 1 is 2 and n is equal. So therefore,
Head to the vending machine.
0 to pi by 2. Same. Sine of 2 minus 1.
Head to the vending machine.
Cos of